Hello everyone, and welcome to today's presentation. I'm excited to introduce you to the fascinating world of Kotlin. The title of our talk is What is Kotlin? And we'll explore how this modern programming language is shaping the future of app development. Over the next few slides, we'll cover what makes Kotlin unique, its key features, and why it's become a popular choice among developers. So let's get started. Let's take a closer look at the difference between val and var in Kotlin. When we use val, we're declaring an immutable property or variable, which means once it's assigned a value, that value cannot change. On the other hand, var is used for mutable variables, so their values can be changed after initial assignment. For example, if I declare val immutable equals 5, I must initialize it right away, and I can't change it later. But if I declare var mutable equals 5, I can reassign it to another value, like mutable equals 14. However, trying to reassign a val, such as immutable equals 14, will result in an error because val is read only after it's set. This distinction is fundamental because it helps us write safer, more predictable code by clearly indicating which variables are intended to change and which are not. Understanding when to use val versus var ties into the overall theme of writing clear and effective Kotlin code. Let's dive into why Kotlin is such a popular choice for Android development. First, it's concise, meaning you write less boilerplate code compared to Java, which helps us develop faster and keep our code cleaner. One of Kotlin's biggest strengths is that it's null-safe, so it reduces runtime errors by catching potential null pointer exceptions during compile time. This makes our apps more reliable. Kotlin also packs in modern features like data classes, extension functions, and coroutines, which make our code more expressive and easier to manage. Plus, Kotlin works seamlessly with existing Java code, so we can adopt it gradually without rewriting everything from scratch. This interoperability is a real advantage. Another key point is productivity and readability. Kotlin's syntax is more straightforward, which helps us write clear, maintainable code faster. And speaking of coroutines, they simplify writing asynchronous and concurrent code, making tasks like network requests or database operations much easier to handle. Overall, using Kotlin aligns perfectly with our goal of building robust, efficient, and modern Android applications. So, how does Kotlin handle type inference? Well, Kotlin is pretty smart when it comes to figuring out a variable's type based on what you initialize it with. This means you often don't have to explicitly specify the type, which makes your code cleaner and easier to read. For example, if you write val message equals hello, the compiler automatically infers that message is a string. Similarly, if you write val count equals 5, Kotlin infers that count is an int. What's really neat is that the compiler determines the type from the right-hand side of the assignment, so you don't have to manually specify it every time. This keeps your code concise without sacrificing type safety. Of course, if you want to be explicit about the type, you can always write it out like val x, int equals 5. But thanks to inference, most of the time your code stays shorter and more natural, which fits perfectly with Kotlin's goal of being both safe and expressive. So what exactly are Kotlin data classes and why should we use them? Well, a data class in Kotlin is a special kind of class designed specifically for storing data. When you declare a class with the data modifier, Kotlin takes care of generating some useful methods for you automatically. These include equals, hashcode, toString, and copy, all based on the class's properties. For example, if I write data class person with a name and age, Kotlin will generate these methods for me. If I create a person instance like this, person equals person, Maya, 35, and then printing that person will give me a neatly formatted string like person, name equals Maya, age equals 35. What's really handy is that methods like toString are auto-generated, so I don't have to write them myself. This makes data classes perfect for modeling simple data structures or plain old data without a lot of boilerplate code. Using data classes ensures that equality checks work correctly and makes copying objects straightforward, which helps keep our code clean, concise, and less error-prone. Overall, They're a powerful tool in Kotlin that streamline working with data, fitting perfectly into the broader theme of writing efficient, clean code. So, what exactly is an extension function? Well, extension functions are a way to add new functionality to an existing class without needing to inherit from it or rely on complex design patterns. It's a really handy feature because it keeps your code clean and flexible. You simply declare a function with a receiver type, which means you're telling Kotlin that this function is an extension of that particular class. For example, imagine you want to add a function to the string class that adds an exclamation mark. You would write it like this: fun string add exclamation, string return this plus. Then, you can call this new function directly on any string like hello, add exclamation, which would return hello. Now, even though we're extending the string class, it's important to remember that extension functions are resolved statically. That means the compiler determines which function to call based on the declared type at compile time, not at runtime. But what makes them so powerful is how naturally they integrate into your code, almost as if they were native methods of the class. This feature is especially popular in Android development, where it helps us add helper methods to existing classes, such as Vue extensions in Android KTX. Overall, extension functions are a great way to keep your code concise, readable, and more expressive, fitting perfectly into the broader theme of writing more idiomatic Kotlin. So let's talk about how Kotlin handles nullability and what nullable types really mean. In Kotlin, the type system clearly distinguishes between types that can hold null and those that cannot. To make a type nullable, you simply add a question mark after the type, like string. This tells Kotlin that this variable might hold a null value, and that's an important safety feature. When you declare a nullable variable, Kotlin forces you to handle null cases explicitly, which helps prevent a lot of common errors, especially null pointer exceptions. For example, if I have a variable declared as var name, string, equals null, it's understood that name might be null. If I want to access its length, I can use a safe call with, like name, length. This way, if name is null, it just returns null instead of throwing an error. There's also the Elvis operator, which is handy for providing a default value in case the nullable expression is null. For instance, I can write val length equals name. Length, 0, which means if name is null, length will be 0 instead of null. The key point here is that any nullable variable must be checked or accessed safely with these operators before you use it. Kotlin explicitly incorporates nullability into its type system to avoid those pesky runtime null errors we often encounter in other languages. This approach makes our code safer and more predictable. So let's talk about the basic data types in Kotlin. Kotlin has the usual primitive types you might expect, like int for integers, long for larger whole numbers, double and float for decimal numbers, boolean for true or false, char for individual characters, and string for text. For example, you might see code like this: val count, int equals 5 or val text, string equals hi. One of the key differences from Java is that, in Kotlin, you don't need to declare primitives and objects separately. Kotlin unifies them under the hood, so it may use primitive types where possible, which can lead to more efficient code. Also, Kotlin's type inference is pretty powerful, so in many cases, you can skip explicitly writing the type, and Kotlin will figure it out for you. This approach makes the code cleaner and easier to read, aligning with Kotlin's overall goal of being concise and expressive. It's a small detail, but it really streamlines how we work with data types in Kotlin. All right, let's dive into sealed classes. So what exactly is a sealed class? Well, it's a class that restricts which subclasses can extend it. This means all subclasses must be defined in the same file, creating a closed type hierarchy. This is especially useful when you know you'll only have a fixed set of types. For example, imagine a class called final result. It could have subclasses like success, error, and loading, all defined within the same file. When you handle a final result, you might use a when expression to differentiate between these cases. The Kotlin compiler knows exactly which subclasses exist, so it can enforce that all cases are handled, making your code safer and less error-prone. Sealed classes are great for modeling restricted hierarchies, especially when the set of possible types is known and fixed. They help ensure exhaustive checks, which means your code can handle all possible scenarios explicitly. This ties back to our overall theme of writing safer, clearer, more predictable code. So let's talk about how string templates work in Kotlin. Kotlin makes it really easy to embed expressions directly inside string literals using the $. This feature is called string interpolation, and it's one of the reasons Kotlin code tends to be more concise and readable. For example, if you have a variable like val name equals Maya, you can simply write println, hello name, and it will print out hello Maya at runtime. You can also evaluate more complex expressions inside a string by wrapping them in curly braces, like name length. This will insert the length of the name directly into the string. The key point here is that string interpolation replaces name or expr with the actual value at runtime, which makes string formatting much cleaner compared to older methods like string format. Overall, this feature helps us write more expressive and readable code, which aligns with Kotlin's goal of making development smoother and more intuitive.